either. And it's not right after lunch, so it's pretty easy. It's bad.
So we're at time. We can give a couple more minutes or get started. Deb, I'll let you see if how the in-person situation looks there.
Yeah, we'll let a few more people trip in, and it'll be fine.
Okay.
Although not a snack break, right? Just a beverage break. Yeah. Yeah, I know. I don't know why, because it's not really a real break. No cookies. All right, I think you're good to go. There might be one or two more coming in, but I think
Okay. Excellent. All right, let's get started. Welcome, everybody. Welcome to KEYTRANS at IETF 124. My name is Prachi. I'm one of the chairs. Unfortunately, Shivan couldn't make it today. He had another commitment. And I want to take this opportunity to thank Deb for very graciously agreeing to run this in person. So thank you, Deb. Oh, we appreciate it.
easy peasy.
All right. So this is our new Note 12. I hope all of you have already seen it. If you have not, this is your opportunity. There's a new shiny QR code. Please scan it, go through the Note 12, and make sure you're aware and you're following the IETF processes and policies. I want to call out, it's okay to disagree with your peers here, but it's not okay to disrespect. So please make sure you're following these policies and processes when interacting here at IETF. I'm going to leave that up for 10 seconds and give everybody an opportunity to scan the QR code, go through it if you haven't already. All right. I'm going to move on. These are the meeting tips. Make sure your audio and video are off unless you are presenting or you're taking questions or answering. Use a headset. And I want to strongly encourage everybody to please make sure you introduce yourself, say your name out loud when you're up on the mic, whether remote or in person. It helps us capture that in the notes, and just for awareness as well. Sometimes it's good to put a face to the name. I know a lot of you by name, but I don't know a lot, still don't know a lot of you by face. So yeah, that'll be very helpful. Okay, these are some of the resources. Moving on to our agenda. It's a pretty light agenda, but first thing first, our main business. We are looking for somebody to help us take notes. I already see somebody on the notes doc. So thank you, whoever that is. Okay, I see Thibault. Thank you, Thibault. So just high level bullet points will do, and I can fill in all the gaps, but appreciate any help with note taking there. Okay, after that, I think Brendan is going to give update on the protocol document, architecture document, And then Felix is going to go with the update on formal verification. I want to take this opportunity to call out, we haven't had a lot of activity or feedback received on the mailing list. So my intent today is to kind of ask people to volunteer here in the room or online to review the docs and send their feedbacks on mailing list during this week, after this week. But we would really appreciate more than one people to volunteer and provide feedback on the protocol document and the architecture document both. So at the end of the call, I'll be asking for it again. So this is your opportunity to think about it and make up your mind if you want to volunteer. Anything from anybody before we move on? Deb, do you have anything? Otherwise, we can move on with Brendan.
Nope, I think we're good to go.
Okay, perfect.
I think it's Thibaut taking notes too, so thank you.
Yeah. Thank you. All right, we will hand it over to Brendan. Let me see if I can share Brendan's slides. All right.
And you can just, if you just pass the slide control to the clicker. So if you click on the clicker, there's a little document with a plus sign in it. Just click on that and it'll pass it to the clicker.
Okay, there you go. All right.
Oh, it's all yours.
Wow.
I know, it's fancy.
Okay, my name is Brendan, and I'm here today to talk to you about our Lord and Savior, Key Transparency. But I'm here to talk to you about the changes to the architecture document and to the protocol document that we've been working on. The architecture document is pretty easy because there have been no changes to it. So that's good. But I did reread the document on the plane here, and there were only really two things that came to mind. The first one was really editorial. There were places where the architecture document was referencing protocol details that have changed in the meantime. And so that really needs to be updated. There are also places where it would be valuable to say, the same thing twice, just in a different way, like common questions that we get. The second more important thing is really this concept of maximum lifetime. So this is a pretty important feature of the protocol document that was added kind of a long time ago. The purpose of that feature is to allow the verifiable deletion of log entries that are old enough that they're not really useful anymore, and so we don't want to keep them in the tree. So that allows pruning the log, so the log doesn't have to grow forever anymore. And it also helps a lot with privacy law compliance because it defines, how quickly things that need to be deleted can be flushed from the log. So that is quite an important feature of the protocol that just was never mentioned in the architecture document. And so my goal is to add that to it. And then after that, those are pretty minor, and I don't really have anything else that I want to add to it. And so I think that's probably ready for last call if there are no further thoughts on that. Okay. And so moving on to the protocol document.
How many people have reviewed that draft?
Okay, actually, I wanted to say something else, but I mean, I have read it.
But has anybody else in the room read that draft? There we go. So you get 2. Recently? 3?
It hasn't changed in a long time, to be fair.
Yeah. 3 months ago.
Yeah.
And no comments? No comments? Okay. Okay.
So one question, I mean, the architecture document will not be published as a standards document, right? So I'm just curious on the formality. This is maybe a newbie question, but what does it mean for such a document to be last called? Then like it's put in the freezer, or what are the semantics here?
I believe it's going to be published as an informational document. And so it is not prescriptive or it's saying things have to be a certain way. But yes, it would be put in a freezer, so it wouldn't be able to change anymore.
Okay. So it goes out of adopted and into published as informational.
Yeah.
Okay, thanks.
But it still has to go through the whole process that everything else goes through. So, right.
Okay. And so moving on to the protocol document, there's been a little bit more substantial change here. So fixed version search, this is the part of the protocol that allows users to search for a specific version of a label that they care about. And the protocol document has this idea of what's called a binary ladder. And so a binary ladder is this series of lookups that a user does to prove something about the versions of a label that exist at a certain point in time, or prove it to themselves. And previously we had 3 types of binary ladder. We had a fixed version search ladder that was for a fixed version search. And so what that would do is it would prove whether or not a target version of a label existed at a specific time or not. And then we had the greatest version search ladder, and that would prove whether or not the target version of a label is the absolute greatest that exists or not. And so the greatest version search ladder is basically the same as the fixed version search ladder. It's just more expensive because you are not only proving that a target version of the label exists, you're also going further and proving that no greater versions exist. And so, yeah, and then you also have the monitoring binary ladder, which is for monitoring, and we don't have to really worry about that. So now that's been cut down. So we no longer have different fixed version and greatest version binary ladders. We just have one type for both, which is called a search ladder. And so to enable that, there's also kind of a change to the algorithm for fixed version search. So previously, all that we did was we would do a binary search for the very first log entry where the target version of the label exists that we care about. And now essentially, so in the previous version, we did this binary search because that's all that our binary ladder told us is whether or not our target version of the label existed yet or not. And so that's all that you need to do a binary search. And so moving into the new algorithm, we do the exact same thing, essentially, is this binary search for the very first log entry where the target version of our label exists. But now we get some more information from our binary ladder. It tells us whether or not our target version, if it doesn't exist yet, it tells us if it doesn't exist. If there are greater versions than our target, it tells us there are greater versions. And if our target version is the absolute greatest that exists, it tells us this is the absolute greatest that exists. And so what we can do with that is we can also stop along our binary search as soon as we find the first log entry where the target version is the greatest that exists. And like I said, we can do that from a functionality perspective because now we have that information from the lookups that we're doing. And we can also do it from a security perspective because the greatest version of a label is generally always assumed to be audited for correctness, right? And so on balance here, there's really no effect on efficiency because each step of our binary search is more expensive, but we do fewer search steps. And so there's not really an effect on efficiency. But the fact that there are fewer types of binary ladder actually makes it a lot easier to reason about the security of the system. Because before, we essentially had 2 different ways that users would come at a transparency log and try and figure things out about it. And then you had to reason like, well, okay, did people approaching the transparency log from these 2 different ways come to the same conclusion? And so now there's only one way that people interact with the transparency log. And so that makes it a little bit more simple. Then there's also greatest version search. This is the algorithm that users use to look up the greatest version of a label if they don't care about a specific version. There have been no changes to that because there didn't need to be. And then moving on, the update algorithm. This is what users use when they own a label and there's been a change to that label's value, and they want to make sure that that change was made correctly. So previously there was no specific algorithm for checking that a label's value was updated correctly. And that's because I kind of assumed that it would be trivial, but it's not trivial. And there are a couple of reasons why. I mean, number one, before I assumed that users would always initiate changes to the label's value. So we could always assume that if there was a new version of a label, it would always be in the rightmost log entry. That's not really true because there are a lot of deployment scenarios where the service provider can kind of always go around in the background and change label values, and it's allowed to do that because it's updating like timestamps or something like that. And really the user's job is just to come online at some point and see, okay, yeah, all the changes that you made while I was gone were correct, but in the time the user is offline and these changes are being made, the log can change quite a lot. And so the user has to step back and check at different points in the log that this was all done correctly. And then the second problem is that It's actually possible for multiple new versions of a label to be created in a single log entry. So in essence, this is saying that multiple new versions of a label can be created simultaneously. And so you can't really handle them one at a time in any kind of trivial way. You have to handle them as a batch that were all created simultaneously. Okay, so yeah, the way this algorithm has turned out working is, so basically when a user comes online, the service provider tells them, hey, I changed your label. Here's the specific log entry where these new versions were added. And what the user does is it considers what's called the previous tree. And if all these little gray boxes are different log entries, all in the log tree, the previous tree is all of the log entries just up to, but excluding the log entry where the new versions were added. And then what we do in that previous tree is we perform what's essentially a greatest version search. And the purpose of that is obviously to verify that the greatest version we get from that is less than the new supposed versions that were added. And then once we do that, we verify that there were no, new versions that we weren't told about right before that new log entry. We go to this log entry, and then we verify that all of the new versions of the label were inserted correctly in the way that we expect them to be. And from then on, this algorithm is kind of done, and the contact monitoring algorithm takes over from there. And so the contact monitoring algorithm is used by both label owners and people who look up a label whenever they see that a change has been inserted very recently. They want to make sure that that change that was inserted just now continues to be integrated correctly into the log going forward. Of course, there have been no changes to that, so that's also good. And then slightly differently, we also have the owner monitoring algorithm. So whereas contact monitoring is kind of a short-term thing that's run by both people that look up a label and people that own a label, owner monitoring is more of a long-term algorithm that's only run by label owners. And the purpose of that is to make sure that for the entirety of the time that I have owned this label, there have never been any unexpected changes to its value or anything like that. And so previously, we essentially had this really short, fluffy description in the protocol document that was like, oh, users check each distinguished log entry for correctness in left to right order. That is correct, but how? It wasn't actually specific enough to be implementable. So it was replaced with what is explicitly a depth first search. So now that algorithm is, for a given log entry, recurse to your left subtree according to some condition, monitor the current log entry that you're currently at, and then recurse to your right subtree if you meet some condition. And so that's exactly the same as left to right order. Is just actually capable of being implemented. And then as part of that, we can also specify how owners should, initialize their state, which you need to get your state from somewhere. So that's important and necessary. Okay. And then moving on to credentials. So, previously we assumed that credentials, what are credentials in the first place? Credentials are basically KT lookups that are intended to be verified offline. And so the use case of that is not really talking to people that don't have a network. The use case of that is more so talking to people who care about anonymity. So they have to use their network in a specific way to preserve their own anonymity. So we're providing them our credentials so they don't have to make any network requests related to us. And previously we assumed that credentials would basically just be a serialized search request, search response kind of pair. And that works, it's just kind of messy. And so the protocol document, we added an explicit credential type. And we were able to make them quite small by reducing, redundant information, because generally we can expect that certain information is already pre-distributed to users, so they can already have some state, and we can assume they have that, and we can not send that again. We're also able to specify the correct verification of credentials rather than, leaving that up to applications, which can be scary. And one of the specific ways that we specify verification is that we say that when you're verifying a credential, any state that you use as part of that has to be sandboxed from the state that you use to verify other credentials. Because if you are mixing state, that kind of does immediately prevent you from having anonymity, because you can target users. But also it's really just a simplifying assumption to make this actually simple and something that can be specified with not too much effort. And so here's the actual definition of a credential. The important thing to notice is that there are two credential types, standard or provisional. Standard is this credential type where we know the user already has some pre-distributed information that we can compare against. And then provisional is for credentials that were issued very, very recently. And we need to provide the user their new state. So when the credential type is provisional, essentially this whole struct is exactly equal to a search operation or to a greatest version search, because we're searching for the greatest version of the label. And it's also verified in exactly the same way. So that's quite nice. And then when credential type is equal to standard, this is more so equal to the very first step of a greatest version search, where we look in the rightmost distinguished log entry. Right. And so all we're doing is one single lookup in a single prefix tree. And that's quite a bit smaller, quite a bit more efficient, because we already know the user has all of the state we need to do this lookup. So yeah, it's relatively small and pretty simple. Yeah. And this is the very last thing that I have to talk about is hot swapping auditors. So there was a change made to the architecture document before IETF 123. That change was essentially to say that when a transparency log has a third-party auditor, it should be secure to change who the third-party auditor is while the transparency log is still operating, because this is a third party. You don't really want to be married to them forever. That would be that would cause a lot of issues, really. And so this is the whole implementation of that. Is it's really just one line, which is to say that when users verify an auditor treehead or a signature from the auditor, they verify that the auditor start position, which is this field in the config that the user is told about. The user is told where the current auditor started auditing. They verify that auditor start position overlaps with where the auditor they talked to last time stopped auditing. So we essentially always guarantee that there is some overlap in where the new auditor started and where the last auditor stopped. Yeah, that's pretty straightforward. It was a lot simpler than I thought it would be. And then to do, I always kind of share my to do at the end of my presentations about what I actually want to work on. I don't have a lot to do here. Basically, just keep implementing the draft and fixing things that come up from that. That's kind of what I've been doing for a while. My code is on GitHub. But yeah, I do have quite a lot of it implemented so far. It's just not 100% complete. So yeah, that's all I got.
All right, we have Felix.
Yeah, hi. I'm wondering about the credentials. It seems like you're having one client do a bunch of queries to the server, standardized already in a different place and shipping that to a different client. Did I get that correctly? For the anonymity purposes, or did I miss something?
Well, so the pattern with credentials is that essentially each user periodically queries the log and learns about the current state of the log. And they do that in a way that is not specific to any particular user. They're just like getting new tree heads and they're keeping that local state. And then the assumption is that if some tree head is old enough, then everybody will already know about it. And so when I give you essentially a search proof, I can prove directly against some state that you already have locally.
Yeah, but the whole idea of credentials is, for example, for a more anonymous communication, right? Where I query my key when I contact you to give you all the proofs on that, so that you don't have to query the log, so that the log doesn't know you're talking to me.
Yeah, that's exactly right.
Yeah. So and when you introduced them, you said like, look here, this is exactly the same as the greatest version search. I wonder. So my question / comment is this something that needs to be standardized on the spec level, or could this just not be handled by the application using the log in a specific way? Because it seems to introduce just one point of full redundancy.
I think that it is valuable to keep it in the standard for the reasons that I kind of have here. Oop, that's not right. For the reasons that I have here, not there. So number one is that there's a lot of redundant information when you do that idea of just serializing greatest version searches. And so it's a little bit nice to be able to strip that out. But I think more important than that actually is
Can you
being
say
able.
what exactly is redundant?
What's redundant is the tree head in the first place, because the user already knows the tree state. And so I don't need to send the tree head again. Also, because it's a credential, it's assumed to be very long-lived. So I don't really care if there's been a new credential issued in the past 3 seconds. Like if this was issued yesterday, that's good enough, you know? Does that make sense?
Yeah, so for the redundancy, I guess it really depends on how fast the log is evolving, right? I may still need to provide the tree version that this greatest version search was produced for this, so that you know exactly with respect to what you need to verify the proof, no? And then with the credentials, I agree with the more long-lived. So like you don't care whether it was the greatest key yesterday or today. Okay, that makes sense. But then I could just send the same search proof again on the application, right? I just cache it as the client, and I don't query the server again. I just send the same thing to all my peers.
That does potentially make sense. I would need to think about it more.
So to me, it seems like more of an application thing. That I mean, I wonder whether there are any famous last words. I wonder whether there are any security implications from these credentials. But it seems like it shouldn't matter.
Yeah, I think that's also why I put correct verification as specified, because one of the things that changes when you have credentials is you want to be able to issue a credential and have it be valid for like a week or something. But you wouldn't accept that same kind of delay if you have a direct interaction with the transparency log. So when you're verifying direct interactions with the transparency log, you would want that to be, I don't know, a couple hours stale at most. But I might accept a credential that's like a week stale.
Why would you?
Why would you?
Why is it okay to apply these different standards?
I think because the idea is that a client issues a credential and then carries it around for a while.
Because you're assuming you're talking to the client anyway. So if they are happy, then you are happy. Is that the idea? Like if you give me the credential for your key, I'm happy because you're the authority over your own key, or
Well, okay, let me explain it a different way. So when you have a credential, what happens is that I encrypt that credential and I send it to you, and you might not be online right now. So it might sit there for a few days while you come online and then decrypt the credential and try to verify it, right? And so that's a valid reason that a credential would need to be valid for longer than a direct request response pair from an online transparency log.
Okay, yeah, cool. Thanks for the elaboration.
Yeah.
Okay, we don't have anybody else in the queue. Any other questions for Brendan? Okay. Brendan, what are you looking for in terms of help? Do you need any help? Do you need any reviews on any particular section of the draft, or you want to work on your to-dos first?
Right. Well, I was going to say what I was thinking is that I would like to get a complete implementation of the draft and potentially also some deployment experience with that. And then after that, I think this document is maybe also ready for last call, depending on how well that goes. Famous last words as well.
You have somebody in the queue.
Victor, yes.
Yes.
Yeah, just a question. Does any of this apply, or is it intended to apply to either DNSSEC or DANE? Have you given any thought to any overlap of or conflict with, or with those also technologies that obviously use keys associated with domain names, right, for TLS or protection of DNS?
Yeah, I mean, nobody has reached out to me about doing some kind of, I don't know, integration of this with DNSSEC or DANE. But if that's like an application that people are interested in, I would love to work on that.
Okay, thanks.
Hey,
Is your GitHub really github.com or github.org?
Is it not supposed to be github.com?
Well, I'm trying to add it to the additional document resources, and it doesn't like github.com.
It's .com.
Okay. You can add it as an additional resource to your draft if you want people to go to that as opposed to the internet draft. Like if you want comments on your GitHub repo, you need to put it as an additional resource.
Okay.
What we can do from a KeyTrans point of view is we can set up the Secretariat can set up a working group GitHub repo, and then you can just transfer your repository into that, and then it's part of the KeyTrans repository and not part of your own personal. So that might actually be the real answer.
Does the IETF want all of my code? I've never heard of that before.
No, well, they'll just transfer the KeyTrans.
So maybe for
pieces.
clarity, the GitHub is development GitHub for the implementation. It's not where the IDs hold. Is that the question that you had then?
I didn't. Can
This
you
is
say
the
that
code
one more
The
time?
GitHub is the
implementation,
GitHub
not
of the
the
implementation.
Oh, yeah. Right. So no, the documentation is what you
Okay.
transfer.
Yeah.
So that's not what that is. That's
Mhm.
actually the code.
This is
Okay.
the implementation, yeah.
Okay. Never mind.
Yes, Thibaut Meunier, Cloudflare. Definitely, I think there's been a couple of iterations of this document with like new improvement to the protocol, which is great to see. I think one question I have, and it might relate to like the question from Victor, is the output of this document meant to kind of like inform existing deployment of key transparency, or is it meant to inform future deployment of key transparency where it makes sense?
I think just, well, so ideally both, right? Like ideally existing implementations and new implementations would both be able to kind of converge on this. What has happened practically in the past is that once people deploy key transparency in like a closed ecosystem, they're like, I already have KT. Why would I deploy something new? And so it tends to be just new implementations, but
Okay.
ideally it would be both.
Yeah, thank you. Yeah, well, one argument I've heard on that is if there was an IETF specification, it might be a motivation to like actually transfer.
Yeah,
But of course, we would need to like vet the implementation and etc. So
yeah, that's a good argument. Okay, thank you so much, everyone.
All right. Thank you, Brendan. Next up, we have Felix.
I don't need the clicker, it's just one slide.
What?
What?
Yeah, it's erroring out on my end to share slides somehow.
Yeah, because I don't know. Shoot. I'm transferring it to you. There you go. Not a very good delegate today.
No worries.
All right. Yours now.
Okay, let's see. And there we go. All right, that should be you, Felix.
Cool. Yeah. Thanks. So unfortunately, like, let me start from the last bullet point. Unfortunately, I still don't have anything definite to announce about the formal verification update. So there is no, like you cannot put a ruler at the progress and see where it's at. However, I can happily say that we have a new team member, Kwok Wai Louis, who is a master student at ETH Zurich. And he will dedicate all of his working time until at least April to work on the formal verification. So these are very nice 6-person months. And that helped us to make progress. But not just that, also other things. I've talked to other researchers at ETH Zurich. So I didn't introduce myself. Hi, I'm Felix Linker. I'm a researcher at ETH Zurich. And I have talked to other researchers at ETH Zurich because last time I said we weren't really making progress. We were kind of a bit stuck. So I asked for new directions. We got new directions. So now we are approaching the problem from a technically new angle, and that helped us make progress. Brendan just said he progressed with the implementation, which will help us too. And there has been related work in the literature, which we will be able to use for parts of the verification efforts, which will speed up things too. So I'm optimistic that we can get some parts of a second implementation, not Brandon's implementation, referenced by the next working group meeting. Yeah, and that is all I have to say. If you're curious about what kind of verification we're doing, I encourage you to take a look at my presentation of the interim meeting that we had. This is where I sketched how I think verification should look. But if you have any questions, if this was unclear, if you would like to know anything, I'm also here now to answer your questions. And that's everything from my side already.
Any questions for Felix? Oh, okay.
Hi, I'm sorry, I forgot to ever join the queue or like join the app, so I couldn't join the queue. But you said the interim meeting for which working group?
For this working group, we had one interim meeting like a year ago, roughly. Yeah,
Okay,
where I first sketched on how I think the formal verification should look like, what kind of properties we verify.
Okay, thank you.
Yeah, sure.
And we can find those details and send it on the mailing list if people are interested in taking a look at the key verification details.
Yeah, or find me on the hallway, pop me an email. I'm happy to talk about it. Cool. Yeah. So I guess I stay below the 5 minutes. Thanks.
Okay, great. Thank you, Felix. Anybody has anything else they want to bring up? Any questions? Okay. So in terms of action items, it looks like we can get started with the working group last call for the architecture document. And then coming back to my earlier question, we're looking for volunteers to review the protocol document and provide Brendan some feedback. I know, Brendan, you mentioned you're working on the implementation, but if we can get 1 or 2 folks to kind of volunteer online or in person and kind of commit to reading the draft and providing some feedback, good or bad, whatever. Even things like, hey, it looks great.
So do you want me to ask whether people are interested in reviewing the draft?
Yeah, it'll be great if we can get,
They could
yeah.
raise their hands.
I volunteer to read the draft, but I don't have a strong cryptography background, so I'll review it for general flow, what an implementer might be able to understand, but not a crypto person.
Yep. I will also review the protocol draft. Take a new read at the architecture draft, even though it hasn't changed. Just at least for the working group last call. One question, and echoing what we had with Rohan. Should we seek more in-depth crypto review for these documents, or would this be part of the process afterwards?
If you want in-depth crypto review, now is the time.
Okay.
The ISG is not those people. So you want to do it before or sooner than later. But that's possibly what you're doing with your formal methods review too, right?
So yeah, just wanted to jump in on that because I think it's important to clarify what kind of properties we're analyzing. I'm not a cryptographer. I did my PhD on protocol analysis in the symbolic model, where we abstract cryptography to some extent. So what I'm looking at in our formal verification are the, let's say, logical relation of the steps between each other, the overall protocol flow, which things can the key transparency server do in its with the operations that are visible to clients, and how do clients consume these updates? How do the different party state transition systems look like, and what can we talk about them? So I think in crypto review, for example, about the construction of the hash function and looking at the collision resistance and similar properties of the underlying authenticated data structures, that would be valuable, and this will probably not be covered by the formal verification that I'm doing. I hope that was clear. I'm happy to answer follow-up questions on the scope of the formal analysis.
Yeah, thank you, Felix. That was helpful. So, Deb, what do you recommend here, in terms of getting a formal crypto review? Who can we reach out to get help on that?
So I think there's people in the working group that would be able to do that. I don't think we're talking fancy crypto here. It's mostly hashes and Merkle trees, right? So it ought to be something that we can handle within the working group. If you think we can't handle it within the working group, we can go and ask for a CFRG crypto review, although they may or may not take it up, right? Because it's not exactly, it's not fancy crypto, right? So, or it's not anymore fancy crypto. Might have originally been fancy crypto. So I would think that we should be able to find somebody in the working group to review it and just make sure that you've got things sort of constructed properly so that you don't end up with vulnerabilities by the way you've put things together. But in terms of like hashes and whatnot, Jonathan, you guys aren't going to review this, are you? No, he says. Damn it. That would have been simple.
Okay.
Yeah, so I think we take it to the working group list and see whether we've got anybody that's willing to, you know,
Yeah.
take it up.
Okay. Perfect. All right. We'll follow up on that.
Jonathan Hoyland's on the list, right? We might be able to get him to review it. So,
I see Jonathan joined the queue.
there we
Jonathan.
go. Look at that.
So I did a bit of implementation, or I attempted to implement some parts of this draft. And I did find some bits were less clear than others. So I will try and get on the list, a list of places where at least I couldn't follow the draft.
That'd be awesome, Jonathan. Thank you.
Yeah, appreciate it. Perfect. So we have some things to take care of here, but I think we're making good progress. Is there anything else we want to cover today? Anybody else want to bring up? Okay, I think we'll give everybody a little over 15 minutes back in that case.
And we'll see you at the plenary. Or
Yeah.
not. It's fine.
All right. But once again, thank you, Deb, for delegating, and thank you to the note takers and everybody else. I think this was productive, and we have some concrete action items to take care. So we appreciate it. All right. Bye, you all.
See you in China. Your little laptop blinky things on the back.